Good afternoon. Welcome to Environmental Engineering and Earth Sciences. For this video, we're going to talk about some of the things that environmental engineers do, what you might see as a career or your graduate school path once you leave the program with a degree. So it's a good profession. If you look at any of the statistics associated with salaries, workplace happiness, things of that nature, environmental engineering always comes out near the top of the lists in things like US News and World Report. It's a good job, and depending on where you go, your mid-career salary will be high, and you'll generally be very, very satisfied with your career according to what gets written about it. We break our market into primarily three areas: consulting, industry and utilities, and obviously government and regulatory. Consulting is where the vast majority of our graduates will likely go. That's because there are the most jobs available there. But if you think of things like water, wastewater, solid waste utilities, energy utilities, those are places where we'll end up, as well as government. And you might even think about a career in law that goes along with that regulatory environment. Now, drinking water, fresh potable drinking water, something we don't need to think about much here in the United States or other developed nations, but a lot of developing nations actually have to worry about day in, day out as one of the biggest areas of environmental engineering. And if you think about it, we look at a picture here of Great Lake Hartwell where we get our water for Clemson. It takes quite a lot of science and engineering to make water from that lake potable in terms of the microbiology and the chemistry. So you students can fill up your water bottles anywhere on campus and not have to worry about, what you're drinking. Now, one a lot of people don't want to think about is wastewater treatment. What do we do with the waste that is generated in food or through human waste or in our showers? But that is a huge field in environmental engineering, and it's an ever-changing field. If you think about it, we can't look at wastewater as pure waste anymore. We have to look at it as a resource. We're trying to recover energy, phosphorus, nitrogen, sulfur, anything we can as a resource from wastewater. So though it has very, very traditional roots in environmental engineering, and it's something that, around the world is not the same level of infrastructure as shown in those photos, it's a really exciting field and one that you'll learn quite a bit about in our program. Environmental remediation broadly encompasses cleaning up contaminated environments: surface water, groundwater, contaminated aquifer, soil, oil spills, metal hazards, metalloids, radionuclides, explosives, energetic compounds, anything you can think of that poses a hazard to human health and the environment. Environmental remediation and how to clean that up using chemistry and biology and physical processes, the engineering of it all, is something we do. So you're going to learn quite a bit of basic sciences that will lead into environmental remediation in those upper level classes. Obviously, municipal and hazardous solid waste is something we as environmental engineers need to deal with. Average person in the United States generates 5 pounds per person per day. And even though we've gotten a lot better at things like recycling and reuse, there's still a long way to go. And we need really, bright young minds that are not tethered by the ideas of the past to come up with new ways to deal with solid waste, as we have an ever-growing population, not only here in the United States, but around the world. And then finally, things like air quality, air pollution, and sustainability. Sustainability sort of links into everything: water, air, energy, all of it. But air quality and sustainability tend to go together very well, because if you think of air quality, that might be more of a global issue. And sustainability, what we leave for future generations and the inputs and outputs of a system, those are things that might have more of a global as well as regional scale. So we've got great classes and research going on in both air pollution and sustainability, and you'll see those during your time here as well. Good afternoon. Welcome to Environmental Engineering and Earth Sciences. And in this short video, we're going to talk about some of the courses you'll be taking in years 1 through 4 and our BSMS 5-year program, as well as some clubs available to you as a student. So in year 1, you're a general engineer. This is where you're going to be with other students. We'll be segueing into things like civil and mechanical, taking your calculus, your physics, your chemistry, and maybe a few specialized engineering courses, either affiliated with the engineering college as a whole or your degree program. It'll be preparing you for year 2 and all the rigors of the engineering college as you move forward. In year 2, you'll have fundamentals of environmental engineering. That's where you'll meet Dr. Friedman, our chair, as well as me again. And in fundamentals 1 and 2, we'll introduce concepts in environmental engineering that you'll need to know for all of your upper level courses. And as you can see, fundamentals of engineering 2, environmental engineering 2, has a laboratory component. And most of those classes will be in Brackett Hall, where our main office is located. In year 3, you'll move on to more advanced courses in environmental engineering and earth science. Our water and wastewater series with laboratory, as well as hazardous waste or environmental sustainability, as well as courses like thermodynamics and fluids, statistics in science and engineering, and a couple of other sci-tech electives or perhaps humanities courses to round out the curriculum. Things will be starting to get a little more interesting here, affiliated with the degree specifically. And then in your senior year, you'll have even more environmental engineering specific courses like air pollution, or your senior seminar, risk assessment, or municipal solid waste. And then you'll have capstone design, which is run by Dr. David Ladner. And if you're interested in that, Dr. Ladner has put together a great video short to explain the entire capstone experience, where you will work with other environmental engineering students to round out the degree program and assist perhaps an industry stakeholder or a regulator in something they need. Now, if you're interested in a bachelor's, master's in 5 years, how that works is during your senior year, you'll take 3 courses at the graduate level that will fulfill your science and technical electives of your undergraduate degree. Those 9 credits plus 21 credits earned in the subsequent year during the MS portion of the BSMS will give you a 5-year BSMS in that time. Some clubs that are available to you are things like Engineers Without Borders, which is college-wide, but we have American Waterworks Association, Sustainable Remediation Forum, things of that nature, places for you to get involved as a student. And of course, our Hydrogeology Field Camp is a specialized course for those interested in groundwater and aquifers. Hello, and welcome to Environmental Engineering and Earth Sciences at Clemson University. This video is going to discuss ways that you can get involved in research as an undergraduate. We're going to go through first, why would you want to do any research as an undergraduate, and then talk about the different ways and places you can get involved, including individual research laboratories in our departmental honors program, for university-specific programs, as well as something called a creative inquiry, which can be run by any faculty member. First question is, why would you want to get involved? Well, clearly there's a lot of benefits to being a researcher. You expand your learning well beyond the classroom and tackle ideas that you might be interested in a great level of detail. It's a real great resume builder if you're applying for graduate schools or for your first job. And of course, you're going to learn a lot of new laboratory skills and field skills as well as data analysis and interpretation. But most importantly, it's going to teach you to be a critical thinker in our field. First place you get involved is any individual research laboratory run by a faculty member, and this can be done for credit as part of a special topics class or for hourly pay. Many researchers, as part of a research grant, need undergraduates to assist the graduate students on smaller research questions that might be applicable during the time that research project is being carried out. And the photos that you're looking at here are actually 4 individual undergrads that have worked for my research laboratory over time, several of whom have gone on to graduate school or employment in a research field. Obviously, the university has an honors college, but within each department there is an honors program as well, and Environmental Engineering and Earth Sciences Honors is a 4-class program in which you will first sit through an honors seminar, kind of learning how to do research. Then you'll have 2 semesters worth of laboratory research done with an individual faculty member with whom you agree in advance to do the research. And then EES 4950, which is like a research thesis where you will present your research as part of a college-wide research symposium. The university has several research areas as well. The most popular is the University Professional Internship and Co-op Program, or also called UPIC. There's about 900 to 1,000 UPIC researchers, and what this is a university-wide program where there is paid research specifically to do work in a particular department. So if you're a UPIC researcher, you essentially work for somebody in environmental engineering and earth sciences. However, you're being paid by the university under its UPIC program. So this is good for both you and the faculty member involved in the research. And then finally, the university has something called creative inquiry. This is like a special topics class, except expanded, where usually multiple students are involved in a creative inquiry project over the course of a semester. And in doing so, they address questions of interest to not only the department and the individual students, but the university as a whole. So you think of creative inquiries, these are more often cross-cutting interdisciplinary areas where you might actually get a chance to work with other people outside of environmental engineering in the other engineering and science disciplines.
Hey, I want to tell you about capstone design in our environmental engineering program at Clemson University. Let's dive in here. Here's a group of students from 2019. We had 24 students, divide them into 6 groups, 4 students per group. It's pretty typical of a capstone design class. I'm going to show you 3 projects. The first project here revolves around drinking water treatment. And this is actually the drinking water that we drink at Clemson University. It comes out of Lake Hartwell, goes through this treatment plant, and here's a slide, or here's a figure from the final report of the capstone design team. The deal is that at this plant, they had recently installed a brand new ozone system. But with an ozone system comes a question of something called assimilable organic carbon. It's organic carbon that bacteria can eat and compose and assimilate into their bodies very easily. So this project involved physical, chemical, drinking water treatment, as well as the biological aspects of that treatment so that we could understand how to provide clean drinking water to people. That's very emblematic of a drinking water treatment project in capstone design. Another project was groundwater remediation. Here was an industrial facility where perchloroethylene had been spilled into the ground, and we're worried about that seeping down into the groundwater and getting into this stream near all these homes. So the students worked with a consulting firm who was our client on the project, and the firm had monitoring well data, and the students put together this plume map to understand where the contamination was occurring and at what concentrations. And then they came up with a design for how would you treat this plume. This involved understanding the chemistry and the biology of how contaminants are degraded. A groundwater remediation type of project. A third capstone design team worked interdisciplinary or interinstitutionally. We had Devin and Robert and Claire and Christina in this case, and we were working with a professor from South Alabama and his students and some other clients down in Alabama, a representative from the Department of Public Health actually. And they were looking at septic systems and municipal drinking water or municipal wastewater systems. So in this part of the country, the soil is not great, and it's not great for septic systems in particular. So the students came up with a master plan for the whole county. Where would you connect a septic system, and where would you connect to the main sewer lines? And if you do connect a septic system, it needs to be designed like this. This is an engineering drawing that they came up with for this septic system. It needs to be designed in a way that it can work with the soil type that's there. Now the students did a lot of community involvement in this particular project too. They came up with this idea with Donuts for Devon, they called it. It was a way to interact with the community and make sure that the community was on board. Now we didn't actually install anything in the community, we didn't have these events, but this was part of their design, the community aspect. And I think that's very emblematic of capstone design. So here's the end of the semester when the students were putting together the final project. We have 2 professors were teaching and a few of our clients were there. And that's really what capstone design is all about, taking all the different aspects of environmental engineering. And I've only shown you 3 projects, drinking water, a little bit of wastewater, and a groundwater remediation. We also do things like industrial wastewater treatment. I have to have my notes here so I can see all the different things that we've done. Air pollution control and permitting, landfill cover design, just a wide variety of things that we do in capstone design, giving the students a real world experience, very similar to the way it'll be when they go out into to work at a consulting firm or a municipality or a government agency. Here's all those students happy to graduate that particular year, successful just like every year with our capstone design program in environmental engineering.